Hello everyone, welcome to Hunt Electronics. This is your friend Saqib, and in today's technical session, we are going to see the full wave rectifier parameter analysis over here. So let us see which are those parameters over there. The first parameter which we are going to do the analysis, it is ILDC. Second, VLDC. Third, ILRMS. Fourth, VLRMS. Ripple factor, or it can denoted by small r also. Sixth, rectification efficiency. And seven, that is a transformer utilization factor of the rectifier. Okay, so let start with first parameter, that is ILDC. So let us start with ILDC, that is the average load current. ILDC. So my dear friends, we all know that full wave rectifier is known as full wave because for both the half cycle you are getting the output at the load. Okay, that's why it is known as a full wave rectifier. And how to find the average load current over here? So ILDC is equals to nothing but 1 upon pi. In a half wave rectifier it was 1 upon 2 pi. Here it is 1 upon pi with respect to 0 to pi. Okay, with respect to 0 to pi, I am sine of omega t dt. Okay, sorry, omega t with respect to d omega t. Okay, so now solving this, we'll get the value for analysis for ILDC, that is the average load current over here. So I can just write here, I can take that I am outside, therefore I am by pi over here. Why minus, I will let you know. So because after integrating the sine of omega t, we are getting a minus cos of omega t. Minus already I have taken outside, so it is a cos of omega t with the limit 0 to pi over here. So I can write here direct I am by pi, so cos of pi minus cos of 0. So we know that what is cos of pi, so this will become I am by pi into minus 2 here it will be, because cos of pi is minus 1 and this is 1, so this minus and minus, it minus 1 and minus 1 becomes minus 2 over here. This minus sign and this minus sign gets cancelled over here, so we are getting here 2 Im by pi. Okay, now in the similar way you can just replace here the Im value by Vm. Okay, so you will get VLDC, okay, value for VLDC, which is nothing but 2 Vm by pi. Okay, just in above equation you can replace all the Im by Vm, so you will be getting the value for VLDC. Or in other way we can just write it, there is another way to find this, just different color over here. So the second parameter which we can find, it is a VLDC, is nothing but we can write straightforward V is equal to IR, like Ohm's law also we can find out VLDC. Okay, V is equal to IR, so that is load over here. So we can write here what is ILDC. ILDC we already know, it is a 2 Im by pi into RL. Okay, now what is Im, we can replace the value of Im, so, or I will just write here. So what is Im, but Im equals to what is Im? Im is nothing but Vm upon R, that is I is equal to V by R, that is a source resistance plus diode forward resistance plus RL. But here RL is very greater than RS plus RL, so we can neglect this. Okay, if we neglect this, we are getting Im equals to Vm by RL. Okay. So replace this value in above equation over here. You will get VL DC equals to, okay, that is 2 Vm whole divided by, already there is pi into RL, pi into RL, this RL into RL. So this RL and RL get cancelled over here. So we are getting here VL DC is equal to 2 Vm by pi. Yeah. So it is the same as this. Okay, you can go with any R method. Okay, both are okay, fine. So I can write here what is LDC. We are getting that is 2 Im by pi, and here I am getting but 2 Vm by pi. Okay, I L RMS. So that is the RMS voltage at the load, at the output. Okay, I element. So it is the RMS. We can write here 1 upon pi. Okay, with respect to 0 to pi, that is the limit which we are going to consider for the calculation. So this is 0, pi, 2 pi. So we are taking that 0 to pi. So as this is RMS, so it will be Im square into sine square omega t into d of omega t. Okay, so here it will be bracket close raised to half. Okay, so this will be now solving for this. So we can write this as equals to, I can take that I am outside, that is Im square by pi. Okay, so 0 to pi. So I can write here the sine of 2 omega, sine of 2 omega t. So sine of 2 omega I can write here 1 minus cos of 2 omega t, okay, whole divided by 2 into d of omega t bracket raised to half. So this is nothing but so I've just replaced this over here, because the sine square omega t is equal to 1 minus cos of 2 omega t divided by 2. Now further solving this, if we further solve for this, we are getting the output as Im square. So here it is at the bottom, we have got 2 over here outside this. So what we are going to get here, okay, further solving this, we can write this as a Im. Okay, so in the bracket we can already we have got that Im square whole divided by pi 2. So here I can write here, after solving this is pi minus 1 by 2 sine of here raised to half. So I already have solved this equation over here, and we know the sine of 2 pi. So sine of 2 pi is equals to 0. Sine of 2 pi is equals to 0. So this becomes 0 over here. Here comes pi, and this pi and pi gets cancelled. So in bracket we are getting here Im square upon pi into 2 into this pi whole raised to half, so which is equals to, so if I, so this and this gets cancelled, and if I open this bracket, what we are getting here, it is nothing but Im by, so this is nothing but ILRMS equals to Im by root 2. So I can write here Im by, so all my friend, in this above equation, if you replace this Im here, if you replace all this Im by Vm, you will be getting VLRMS. Okay, you are getting a VLRMS, which is equals to what? VLRMS equals to, that is a Vm by root 2. So you will get this equation over here. Okay, but let us solve in other way. So there is one more way which we can solve this equation. VLRMS equals to, okay, VLRMS equals to over here, that is nothing but ILRMS into RL. So that is nothing but V is equal to IR. So we know what is Im. So Im is nothing but into RL. But what is Im? We know what is Im. Im equals to, that is Vm by RS plus RF plus RL as RL is very greater than RS plus RF. This can be neglected over here. So if I neglect this, Im becomes Im by Im equals to Vm Vm by RL, and this value we are supposed to replace in above equation. So just replacing this in the above equation, what we are going to get, it is nothing but a V L R M S. Just substitute this. So we are getting here Vm by RL into root 2 into RL. So this and this gets cancelled. So VLRMS equals to Vm upon. So you are getting a same equation as over here. So I can write here this as nothing but a Vm by root. Okay. So